It is a locale. Dark openings may very well be one of the most entrancing and baffling peculiarities in the universe. They are huge monsters as far as power and yet essentially imperceptible to us. A dark opening gauging maybe 2 to 4 million times the mass of the Sun. But since of the exploration that was placed into them over the last couple of many years, we've gone from knowing literally nothing about them to getting to find out increasingly more very close and individual. And keeping in mind that things have simply gotten more insane, Mukaku recently reported that we at last got check what's outs inside a dark opening. And this new data carries light to the subtleties the universe of science could have missed from the start. Go along with us as we dig further into dark openings and divulge what's inside. Space is large terrible. Before we get into the subtleties of what Mukaku found, we need to discuss the principle. Despite the fact that the majority of us have some thought what dark openings are, there are still a few holes justified. Data. You see, in 1916, Albert Einstein distributed his hypothesis of general relativity, which anticipated the presence of dark openings. Around then, the idea of dark openings was absolutely hypothetical. It required an additional 50 years for the logical local area to track down proof that dark openings really exist. This occurred in the 1960s. They were concentrating on the C's group of stars when they saw a strangely dazzling blue star that was radiating X-beams. This star was definitely not a stale object, however, was circumventing a monster dark something. Upon further examination, it was viewed that as the X-beams weren't simply moving around on their own, however, they were being sucked into the dark thing they were circling. Consequently, the name dark opening. This revelation was huge on the grounds that it gave confirmation that dark openings really exist and that they were only a fabrication of Albert Einstein's wild creative mind. Well, that was perfect. However, it additionally intended that there was this stunning element in space that we desperately had to know more about. So, researchers generally around the world got to work. This dark opening was named SX1, and it is situated in the star grouping CIS, around 6,000 light-years from Earth. And it was no little revelation. It's multiple times more brilliant than the Sun and incredibly thick, which makes it have areas of strength for a pull. The gravitational draw is so solid that not even light can get away from it. This is why it is known as a dark opening. The idea of a dark opening is both captivating and terrifying. It is to unnerve it locale of room where gravity is so solid that nothing, not even light, would be able to evade. Whatever gets excessively near a dark opening won't be maneuvered into it ever to be seen again. However, that part of peril makes it considerably more important to learn all that there is to be aware of them. Was this it? Or were we just beginning? The response turned out to be the last option. After the revelation of SX1, researchers began to look for other dark openings. They found that there might be near more than 100 million dark openings in the smooth way alone. But since they are so inconceivably difficult to identify, we still try not to have an precise number. By the looks of it, there are several million dark openings in the smooth way, in our very world, which is what makes them considerably more essential to concentrate. So how about we separate it? The fundamental worry with dark openings is continuously going to be gravity. Their gravitational force is extreme to the point that anything that enters it packs down cosmically until it turns into a peculiarity. In easier terms, dark openings resemble inestimable vacuum cleaners that suck everything in. One of the most alarming parts about the examination that has gone into dark openings is the reality that if somebody somehow managed to fall into one, they would come to the heart of the matter that they become a solitary line. This cycle would happen gradually, and the individual would pass on before the last structure, as a matter of fact, sets in. So let's just say that no one ought to step into one. But they're everywhere, so might we at any point truly be in peril? Regardless of the way that the nearest dark opening to Earth is 1,500 light-years away, it's actually close enough to raise questions and worries. In 2021, researchers had the option to deliver the first clear photo of a dark opening, explicitly the M87 dark opening. This dark opening was captured a few evenings in succession, and with each photo, the analysts assembled to an ever-increasing extent proof about it. They needed to join the individual photographs together to make something that filled every one of the gaps. This way, they had the option to sort out that there are 3 layers to a dark opening. It's not only one single expanding opening of nothingness, as many individuals accept. Things are much more convoluted than that. To try and get to the nothingness part of a dark opening, you need to make it through the initial 2 layers. The first layer is known as the occasion skyline, which, while in the principal layer, is the point of no return. Once you pass the occasion skyline, there's no option but to press onward, and you will be sucked into the dark opening. It just deteriorates from that point onward. The second layer is the photon circle, which is the locale where light circles the dark opening. Any light that enters this locale will be caught and cannot get away from the dark opening's gravitational draw. At last, we come to the third layer, which is the peculiarity. This is where everything that enters the dark opening gets compacted down cosmically until it turns into a peculiarity. The peculiarity is a point in spacetime where the laws of physical science, as we probably are aware them, separate, and we can't anticipate what occurs straight away. Presently, what makes all of this limitlessly more regrettable is the way that each and every dark opening you study will be totally unique in relation to the last. Sure, they do generally follow a similar 3-layered idea, but the manner in which they capability could be immensely unique. Now, assuming this were whatever else, we should simply bounce back on those telescopes and simply study the main pressing issue exhaustively. But with dark openings, you can't actually do that. Researchers can concentrate on dark openings in a roundabout way by noticing the radiation they transmit and the gas and residue that surrounds them. Sending a test like the Explorer inside a dark opening isn't conceivable on the grounds that anything that enters the occasion skyline is pulled towards the peculiarity, where it is compacted to a vastly little point. So you can't precisely squander billions of dollars just to get a glimpse. Each time, because the second the test draws near enough, it'll just squash into nothingness. Because of the obvious issue, researchers are left with no option except for to concentrate on these objects in a 2-layered way. Despite the fact that they are 3-layered peculiarities in reality, to make matters significantly more, it are likewise the 2 to challenge. They're issues of each and every dark opening being unique and the laws of physical science as we realize them separating when we attempt to investigate within. This implies that the conventional methods of logical request don't actually apply to the review of dark openings. That doesn't really mean that the researchers haven't been occupied. There are loads of various hypotheses and clarifications of dark openings. And well, with every one, things get to an ever-increasing extent fascinating. One of the most convincing hypotheses about the arrangement of dark openings is that they are made from imploded stars. When a star depletes all of its fuel, it can never again deliver enough energy to balance the power of gravity that is continually pulling internal. Thus, the star begins to break down in on itself, reducing and denser. Assuming that the star is sufficiently gigantic, this cycle can go on until it turns into a peculiarity. To comprehend the nature of dark openings top to bottom, NASA researchers directed their concentration toward the center of the world M87. Cosmologists noticed a solid whirlpool of very hot hydrogen gas that was turning at an astounding pace of 1.2 million miles per hour. The sheer power of this turning circle of gas ought to have made it brutally fly separated this way and that. However, it didn't. Researchers found that there must be a titanic mass accumulated at the focal point of the world to keep this from happening. This monstrous object weighed as much as 2 to 3 billion suns and must be a dark opening. Yet, that's by all accounts not the only hypothesis. In 1963, the New Zealand mathematician Royer utilized Einstein's conditions of gravity to give the best depiction up to that point of a turning dark opening. KR showed that a turning dark opening wouldn't implode into a point as recently thought but to a ring of fire or, on the other hand, a slight plate. The circle would be turning so quickly that radial powers would hold it back from imploding. This turning circle of matter is called the ergosphere, and it is the region encompassing the dark opening where the laws of material science begin to separate. However, the most fascinating component of mongrel arrangement was that it anticipated the presence of an Einstein-Rosen extension, otherwise called a wormhole. This is a hypothetical section through spacetime that associates 2 discrete areas of the universe or even 2 equal universes. The thought is that if one were to fall into a dark opening, rather than being squashed to a point, one would be sucked down a passage through the ring of chute and shot out a white opening in an equal universe. These thoughts and hypotheses have all gotten on the 2019 effort to take the first photo of a dark opening that also established the Event Skyline Telescope. scientists successfully photographed the dark opening in the galaxy M87, and it was a historic achievement that provided a visual confirmation of these mysterious objects. The image showed the shadow of the dark hole cast against the glowing gas swirling around it, which is exactly what scientists expected to see based on Einstein's theories of general relativity. This image not only provided evidence for the existence of black holes, but also opened up new possibilities for studying their properties and behaviors in greater detail. In conclusion, while dark holes remain one of the most mysterious and fascinating phenomena in the universe, they are also some of the most difficult to study due to their extreme gravitational forces and the fact that they cannot be observed directly. However, recent advancements in technology and observational techniques have allowed scientists to gather more information about these enigmatic objects than ever before. As our understanding of black holes continues to grow, so too will our ability to explore the deepest and most profound mysteries of the universe. The discovery of a black hole, a dense region in space where gravity is so strong that not even light can escape, has revolutionized our understanding of the universe. First predicted by Albert Einstein's theory of general relativity in 1916, black holes remained a theoretical concept until the 1960s when astronomers began to discover indirect evidence of their existence. One of the key pieces of evidence came from observing the behavior of stars orbiting an invisible companion. These stars exhibited unusual movement and emitted X-rays, indicating they were in close proximity to a massive, unseen object, a black hole. This indirect observation provided the first compelling evidence that black holes are real and not just a theoretical construct. Since then, scientists have made significant progress in understanding the nature and behavior of black holes. They come in various sizes, ranging from stellar mass black holes formed from the collapse of massive stars to supermassive black holes found at the centers of galaxies, weighing millions or even billions of times more than the Sun. The structure of a black hole is defined by several key features. The most well-known is the event horizon, the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. Inside the event horizon lies the singularity, where the laws of physics as we know them break down. Here, matter is crushed to infinite density, forming a point of infinite gravitational force. Despite their mysterious and extreme nature, black holes play a crucial role in shaping galaxies and the universe at large. They can influence the movement of stars and gas around them, affecting the formation and evolution of galaxies over cosmic timescales. Recent advancements in technology, such as the development of gravitational wave detectors like LIGO and Virgo, have opened up new avenues for studying black holes. Gravitational waves, ripples in spacetime caused by the movement of massive objects like black holes, provide a unique way to observe these elusive cosmic phenomena. By detecting gravitational waves emitted during the merger of black holes, scientists can infer their masses, spins, and even test fundamental aspects of Einstein's theory of relativity. Looking ahead, future missions and observatories, such as the James Webb Space Telescope and the Event Horizon Telescope, promise to deepen our understanding of black holes. These instruments will allow astronomers to study black holes across different wavelengths of light and capture more detailed images of their surroundings. In summary, while black holes remain one of the most enigmatic and fascinating objects in the universe, ongoing research and technological advancements continue to unravel their mysteries. By probing the extreme physics near black holes and observing their interactions with their surroundings, scientists hope to gain insights into the fundamental nature of space, time, and gravity itself. Black holes represent some of the most extreme and mysterious entities in the universe. These cosmic objects, characterized by their immense gravitational pull, are regions where gravity is so strong that not even light can escape from them. The concept of black holes emerged from Albert Einstein's theory of general relativity, which predicted their existence as regions of spacetime where gravitational forces become infinite, leading to a singularity, a point of infinite density. The first indirect evidence of black holes came in the 1960s when astronomers observed stars orbiting around invisible companions in binary star systems. These stars exhibited unusual movements and emitted X-rays, suggesting they were orbiting around massive but invisible objects, black holes. Since then, advancements in observational astronomy and theoretical physics have allowed scientists to deepen their understanding of these enigmatic cosmic phenomena. Types and formation. Black holes are broadly categorized into several types based on their mass and how they form. The most common types include stellar mass black holes, intermediate mass black holes, and supermassive black holes.